Hello everyone, greetings of the day. In our earlier session, we saw how Asavas, Arishtas, Ghutikas and Bhasmas are prepared. So these are the liquid and solid oral dosage forms used in traditional system of medicine. We saw the preparation of these dosage forms. How do we ensure that whatever is prepared has good quality, ensuring their therapeutic efficiency or accuracy? Hence, there is a need for standardization, and the need for standardization is now stressed by WHO. It has been mentioned by Ayush, and if our traditional system of medicines have to be accepted globally, standardization becomes a must. Standardization also ensures batch to batch consistency for therapeutic efficacy. So let us see how these Asavas, Arishtas, Ghutikas and Bhasmas are subjected to quality control test. Standardization ensures safety and purity of the formulations. It tells us that these formulations are free from contaminants, microbes or any kind of adulteration. Since these formulations are known to contain more than one ingredient, unlike our synthetic forms where there is just one single API which comes with a certificate of analysis. Here all this comes from nature, and anything which comes from nature is subject to lot of changes. Hence, to maintain the efficacy and quality across batches, it is very important that we have consistency of the active principles which is present in the herb. Scientific validation is very well known these days with modern method of analysis used for different traditional forms, and this transforms our traditional knowledge into an evidence based medicine which is accepted globally and which can be integrated with modern day healthcare. There are a lot of regulatory guidelines which are mentioned by WHO and Ayush, where these traditional medicines have to comply with these guidelines and comply with the drugs and cosmetic acts, then only it can be allowed for export. Why does standardization of herb maintain efficacy? It ensures an consistency of active compounds. Herbs are subject to a change in the chemical composition because of differences in soil, climate, harvesting and storage. So, the pH of soil, the content of the soil, what is the nitrogen content, how much is the pesticide present in the soil, what is the water retaining capacity of the soil, what is the fertility of the soil, all this directly affects our composition of the active components. For example, the nitrogen content of the soil is very important for growing plants which are rich in alkaloids. Climate changes, if there are sudden climate changes, this causes stress in the plant, and there are some special compounds which are produced because of this stress. Resveratrol is one such compound which is known to be differing in the constituent because of climate changes. Standardization ensures us batch to batch variation in the ingredient, giving us a reliable therapeutic action. Also, the herbs which are obtained from different geographical source. For example, ashwagandha when it is obtained from Rajasthan and ashwagandha when it is obtained from Madhya Pradesh, because of the change in the soil and climate, the active constituents of the alkaloids in ashwagandha varies. So, it is very important to note that in such cases standardization ensures consistency in active constituents. Reproducible clinical effects, once there is consistency in active compounds, it will give us reproducible clinical effects. Proper testing during standardization reveals the presence of contaminants. WHO and Ayush both mention the limits for pesticides, heavy metals and microbes. This is called as microbial bioburden, which is present on the herbs during extraction or during formulation. So, this ensures the safety while maintaining the efficacy. There are different parameters which have to be done on the herb or on the formulation, which involves organoleptic, organ, lepsis means senses. So, what impression the herb gives on 5 sense organs is organoleptic evaluation, physicochemical and phytochemical evaluations guaranteeing high quality of the herbal medicine. Scientific validation gives credibility in modern medicine and ensures therapeutic efficacy. Thus, standardization ensures that herbal medicines are safe, consistent and effective by controlling the quality and maintaining the right concentration of active principles. Let us now see the standardization of Asavas and Arishtas. If you remember, these are Ayurvedic liquid formulation prepared by soaking drugs using a sugar base and undergoing natural fermentation. So, there is self generation of alcohol which extracts the active constituent, and this alcohol content is 5 to 12%. So, here is an example of Khadira Rishta, where you can see this is a liquid oral formulation, and here it is mentioned what is the alcohol percentage. So, here it is mentioned that this contains 11% alcohol which is generated. So, this lies between 5 to 12. There are different ingredients mentioned. The quantity of the ingredient which is used. So, this is a polyherbal formulation, and each herb which has gone into the extract of making this is mentioned here, and finally it gives for what health benefit this is used. So, the first part of standardization must mention the amount of alcohol generated. Examples of different Asavas and Arishtas: Draksha Sava, which is made from grapes and this is used as a digestive tonic. Kumar Asava, made from aloe, this is used for women health, for menstrual problems. Arjuna Rishta is used as a cardiotonic. Dashamula Rishta, which is made from 10 roots, is used for general health. Parameters: the most important one is organoleptic tests. So, organoleptic is using our 5 sense organs, the appearance or color using eyes, the odor using nose, the taste using our tongue, and the appearance is using the touch. So, skin is a very important sense organ. Ears are used to find out the kind of fracture the drug shows or the sound of fracture which a drug shows. Some drugs are fibrous. So, when you try to break it, it does not give a clear snapping sound because there are a lot of fibers. Arjuna is one such bark. So, by hearing the sound of fracture of the drug, we can kind of ensure or authenticate the drug. Physicochemical test, very important for Asava and Arishta, is the alcohol content, which lies between 5 to 12. The pH, because on storage, if the pH changes beyond this, it shows that it is not stable. Specific gravity and the total solids. So, the total solids tell us how much amount is extracted. Here is an example. Let us see the standardization of Drakshasava. The color is typically dark brown to reddish brown. Odor is characteristic alcoholic. The alcohol odor is because of self generation of alcohol, and the fruity odor is because of grapes. So, if you observe, if grapes are left open for a few days, they will give you a peculiar typical smell. That fruity smell you have for Drakshasava. Taste is sweet, slightly sour because of fermentation and astringent. Appearance, it is a free liquid. There should not be presence of any suspended particles, and consistency is thin. So, if you see here also, this is very thin liquid. So, it gives a sound also. If it is thin, when you shake the bottle, you can make out the consistency. So, this is the organoleptic evaluation. Considered a dark brown liquid, fruity odor, alcoholic, sweet and sour, clear appearance and thin consistency. Another example is Asava, which has an aromatic. All Asavas and Arishtas have an alcoholic note, alcoholic and aromatic note, and Asava is made from Arjuna, Haritika and lotus. So, the astringent taste feel comes from the bark of tannins of Arjuna. It is again a clear liquid, no suspended matter, thin consistency and sweet bitter. So, the bitter taste is because of the tannins. Modern methods can be used for standardization: thin layer chromatography, high performance thin layer chromatography, high performance liquid chromatography can be used for fingerprinting of marker compounds. What is a marker compound? A marker compound is that major constituent in a plant which is responsible for activity. A marker compound as defined by WHO can also be something which is present, not really directly responsible for activity, but may be synergistically acting and responsible for activity. For example, arginolic acid from Arjunarista. Arjuna also has a glycoside bicalin which is responsible for cardiac activity, but we can use arginolic acid also as a marker compound. Kumara Asava, which has aloin, which is the glycon from that anthraquinone, can be used as a marker compound. For Drakshasava, resveratrol can be used as a marker compound. Microbiological evaluation to ensure that our formulation is free from any microbial load, and even if present, it falls within limits. There should be a total absence of E. coli, salmonella, any kind of yeast or mold. So, parameters for standardization is, when you are making a TLC for standardizing Drakshasava, we have to extract this from the Asava. So, take 5 ml, evaporate it completely and then dissolve it in methanol. This is then applied to plate. A mobile phase is developed and the fingerprinting is observed. So, by running a co-chromatography with the marker compound resveratrol, if the RF matches. So, this is a detailed procedure considered under the modern method of analysis, where we can detect the presence of resveratrol in an asava. An ideal characteristic thus for any asava and arishta is it should be a clear liquid free from any foreign matter. It should have sweet, alcoholic, aromatic odor and taste, and the characteristic depends on the kind of herb used. The alcohol content, which is self generated, should be between 5 to 12%. The pH should be between 3 to 5, specific gravity 1 to 2. Total solids as mentioned in Ayurvedic or herbal pharmacopoeia. Total absence of any microbial bioburden, and the shelf life is generally 10 years, but it should be checked for stability, because if it absorbs moisture, the shelf life reduces. Gutika, which is our solid dosage form in the traditional system of medicine, made by mixing herbs with binders. So, this is standardization of gutika ensures safety, purity, quality and therapeutic efficacy. Different types of gutikas: Chandra Prabha, Chandra means moon, Prabha means glow, used for urinary and metabolic disorders. Kanchanara Gugulu, which is combination of herbs with gugul, used for thyroid and glandular swellings. Triphala is mixture of 3 fruits, Harda, Behda and Amla. Yogendra Rasa uses herbs which is used for neurological and cardiac disorders. So, the appearance of any gutika should be uniformly round and a smooth surface. No cracks should be seen after drying, and the color depends on the ingredients used. So, Kanchanara Gugula shows blackish brown color. Weight variation test is done, and each pill or each gutika should have uniform weight to ensure uniform therapeutic potency. Hardness and friability: not too friable so that it crumples in hand, and not too hard. So, this is done using the tablet hardness tester. Disintegration time should be within 1 hour so that it disintegrates in the stomach. Loss on drying: moisture content should not be much, else it gives rise to microbial growth. So, this is done by any one of the methods used to find out moisture content. The easiest one is loss on drying. Heat it and weigh it, reheat and reweigh it. The difference in weight will give you the amount of moisture present. Ash value tells us if there is any inorganic adulteration present. This is generally done on the herbs before we make gutika. Extractive value tells us how much active constituent the herb yields to the solvent, and this a good extract, for example, for licorice it should not be less than 10%. pH should be suitable for the formulation. TLC, HPTLC, HPLC for these vatikas has been reported in a process mentioned in the earlier slide, and for Gugulu, estimation of gugulosterones. For Chandraprabha Vati, estimation of catechins. This is a group of tannins, flavonoidal compounds, and for Triphala, gallic acid and ellagic acid, which is present in all the 3 components of Triphala. Microbial assays. So, when you incubate the extract of a gutika onto a medium and see if it gives rise to any growth, you must not see growth of E. coli, salmonella or any kind of microorganism. Heavy metal testing is done by atomic absorption spectroscopy, and if the plant has absorbed any heavy metals from the water, then it may show presence of these heavy metals. So, WHO and Ayush is making it kind of mandatory these days for testing of heavy metal after several heavy metal toxicity has been reported. Very important to check the pesticide residues if lot of pesticides are sprayed during cultivation, and detection of aflatoxins. Aflatoxins are fungal metabolites which are present on the drug during storage either of the extract or the herb. Coming to gutikas, the external characteristic appearance should be uniform, smooth, weight variation of not less than plus or minus 5, hardness like I mentioned not too brittle, it should withstand when it is packed during transport, when it shakes it should withstand the handling. Disintegration time ideally 30 minutes to 1 hour, friability, moisture content, uniform mixing of ingredients. So, when you extract it from say 5 pills, if you get uniform content, that means there is uniform mixing of ingredient. It should be free from microbial contamination. Coming to bhasmas, which is an Ayurvedic formulation using metals, metalloid and a process of incineration and shodhana. Traditional methods for standardization or finding out if the bhasma formulated is proper or no. So, the first test is floatability test, varitratva. What they do here is a pinch of bhasma is sprinkled on still water, and if it floats, it shows that the particle size is so small that it literally floats because of fineness and lightness. If it sinks totally at the bottom of the water, which means the one of the process carried out is not correct. Traditional method of standardization also includes rekha purnatva, where a pinch of bhasma is rubbed between two fingertips like this, and then you see whether the powder is entering into the fine lines and is not easily removed. This indicates, so this indirectly tells us that bhasma has achieved the particle size desired for fineness. Another method is niswadu. When you taste it, it should be tasteless, it should not have the raw metal or mineral taste. Nirdhumata is smokelessness test. So, when you heat a bhasma, it should not emit smoke. This if it emits smoke, it tells us that the puta process is not completed properly. Apurna bhava is the irreversibility test, where the bhasma is mixed with specific reagents like jaggery, gunja seeds, honey, ghee, etc. When it is mixed, it should not revert to its metallic luster. If it reverts, which means that the process is not completed. Nirutha or the non-reactivity test. This is heated with silver or gold in a crucible. It should not melt or form an amalgam, showing that the metal is fully converted into its stable calyx. So, these are the 5 kind of traditional standardization tests which are done: varitratva, rekha purnatva, niswadu, nirdhumata, apurna bhava and nirutha, to ensure that bhasma is properly formulated. And when it passes the test, we can say that it has reached a micro or nano range, which can be confirmed with modern day XRD analysis which tells us that the structure is crystalline. The scanning electron microscope can be used to determine the particle size of the particle. FTIR can be used to detect whether the metal has completely fused into the herb. So, the functional groups can be detected and the pH and solubility is increased, which leads to increased bioavailability. Loss on ignition or ash values to assess the purity. Atomic absorption spectroscopy to detect if there are any unconverted metals left. Energy dispersive X-ray qualitatively and quantitatively analyze the metals and minerals present, and these are examples of some of the bhasmas. Ghutika Bhasma, which contains silicate of magnesium and iron, Swarna, which contains gold nanoparticles, Tamra, which contains copper oxide particles. Very important to ensure the safety and toxicity, else the metal toxicity is very hazardous to the body when bhasma is administered. Heavy metal must be bioabsorbable, there should be microbial safety. Animal studies may be done if bhasma is made using modern day methods. For example, the furnace and other methods, if they are used, it is better to do an animal toxicity study and a modern pharmacological evaluation. So, the ideal characteristics are it should float on water, fill between the finger lines, should not have any luster, should not revert when mixed with ghee or other ingredients, no amalgam with silver or copper, it should be of nanoparticle size and free from toxicity. These are some of the references. Thank you very much.